Shall we start the class? Any one of you? Unmute the mic. Whether I am audible?
Yes, ma'am.
Okay.
Yes, ma'am.
Yes. Good morning, students. I am Dr.M.Malathi, Associate Professor of Physics Department. From today onwards, I am going to handle this physics class, bridge course class to you. Okay. Now, today's topic, I think Dr. Thamizharan sir have took you all these chapters, first unit, regarding first unit, he took the class and he have completed up to acoustics. About sound wave, he have told something and he have talked about acoustics. You know what is acoustics? Acoustics. Before that, I will give you a small brief introduction about sound wave, because sound wave is an sound wave. It is I will start from the fundamental starting. Just I recollect for 2-3 minutes. You know that sound wave is a mechanical wave. Sound wave is a mechanical disturbance produced in an elastic medium. Sound wave is a mechanical disturbance produced in an elastic medium. That is, from the definition itself, you know that you need a medium, something solid, liquid or gas. Some medium is necessary to generate a sound wave. And sound wave is a mechanical disturbance in an elastic medium. Means, from that, what do you understand means mechanical disturbance? It is the some vibration of the particles. It is due to the mechanical vibration of the particles in a medium. The sound wave is produced. So sound wave is it is produced by the mechanical disturbance in a medium. That is, it is produced due to the vibration of particles in a medium. So to generate a sound wave, you need a medium. You cannot produce sound wave in a vacuum, because vacuum there is no particles. So there is sound wave can be produced only due to the vibration of the particles in a medium. Okay, so sound wave is a mechanical disturbance produced in an elastic medium. Why we are telling about the medium to be elastic is, see, if the particle is vibrating in a medium, there will be a distortion produced. There is a change in the shape and size of the medium. But because of the vibration of the particle, there should not be disturbance or distortion in the medium. The particles, after come to its original position, after vibration, the medium also, it comes back to its original shape and size. So sound wave is produced due to the mechanical disturbance in an elastic medium. That is, the sound wave is produced due to the vibration of particles in an elastic medium. So sound wave cannot be produced in a vacuum. To produce sound wave, you need a medium. Now what I have to tell you is, in that sound wave, it based on the frequency, because wave, he have told all the basic parameters to describe a wave. Wavelength, it is the average distance traveled by the wave in a unit time. Then what is time period? Number of oscillations per second, and is called frequency. Time period is the time period is time taken for one oscillation is time period. So number of oscillation of the wave per second is called frequency, which is measured in hertz. Time period measured in second. Wavelength measured in meters. Everything sir have told you while he is starting the syllabus. Then again, about the sound wave, based on frequency, it is classified as audible sound wave, infrasonic wave and ultrasonic wave. These are the some classifications of sound wave based on frequency, that is the number of oscillations per second. So That is infrasonic sound wave means the sound wave which is having a less frequency. So less frequency means, you know, E is equal to h mu. Energy is equal to h mu. If the frequency is less, energy is also less. So less energetic sound wave is called infrasonic, because infrasonic sound waves have frequency less than 20 hertz. Then another sound wave based on frequency is audible sound wave. The sound wave which is produced by a human being. So or any sound wave which is produced is sensible to human ear. That is called audible sound wave. Sound wave having frequency between 20 hertz to 20 kilohertz. They are called audible sound wave. That this range of frequency of sound wave produced only is sensitive to human ear. So it is called audible sound wave, whose frequency lies between 20 hertz to 20 kilohertz. Then next is ultrasonic wave. That is, I am going to start in detail. Ultrasonic wave are sound waves whose frequency is greater than 20 kilohertz. So it is a sound wave which is having high frequency. So it is a highly energetic sound wave. These are something about the basic introduction. While I am recollecting, I think everything sir have taken detail. Then in sound wave, in ultrasonic wave, we are going to start in detail. Before that, you must know the sound wave means it will propagate in the form of crest and trough. That concept he have told. Now, crest means region of compression. Trough means region of rarefaction. That is, when a sound wave propagates in a medium in the form of crest and trough, wherever there is a formation of crest in the medium, that point, it is subjected to high pressure. Wherever there is a trough, that region is subjected to low pressure. So, see, here I will tell you. See, the sound wave will propagate in the form of crest and trough. This is called crest and this is called trough. So, sound wave, wait 1 minute. So, crest and trough. C-R-E-S-T, crest, T-R-O-U-G-H, trough. So, sound wave will propagate in the form of a crest and trough in a medium. Crest is the region of, in a medium, if a sound wave propagates in the form of a crest and trough, in the medium, wherever there is a crest, that region in the medium is subjected to high pressure, and wherever there is a trough, that region in the medium will subjected to low pressure. That is compression and rarefaction. Compression is the region in a medium where its pressure is more. Rarefaction is the medium at which it's that region the pressure is less. So compression and rarefaction in the form of when a sound wave propagates through a medium in a form of crest and trough, it will produce a region of high pressure, compression, and region of low pressure. That is rarefaction. These are something about propagation of sound wave through a medium. Okay, now we will go for ultrasonic wave. Before that, I have to present this slide. Wait 1 minute. Can you see the slide? Any one of you?
No, ma'am.
No, ma'am.
No, ma'am.
Wait 1 minute. Who is Suvita? She is presenting. Suvita, stop presenting, ma. Can you see now?
No, ma'am. Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Now, okay. Now, we are going to see in the sound wave, ultrasonic wave. Ultrasonic wave. See, before 5 minutes before you tell me, I have to mark the attendance. Okay. Now, ultrasonic wave. Ultrasonic wave are the sound waves having frequency greater than 20 kilohertz. So, based on frequency of a sound wave, somebody is making noise. You unmute your mic. Now, ultrasonic waves are the sound waves whose frequency is greater than 20 kilohertz. So, you know, infrasonic wave based on frequency, the infrasonic wave means its frequency is less than 20 hertz. Audible sound wave means its frequency is lying between 20 hertz and 20 kilohertz. But ultrasonic waves are the sound waves having frequency greater than 20 kilohertz. Now, see. Next. Wait. Now, see, in this diagram, in this picture, you see sound wave which have frequency less than 20 hertz is called infrasound. Then 20 hertz to 20 kilohertz, that is infrasonic sound. Very low frequency sound wave is sensitive to elephant's ear. That is the meaning. Now, the sound wave having frequency between 20 hertz to 20 kilohertz, that is 20,000 hertz, is audible sound wave. It is sensitive to human ear. Now, the sound wave whose frequency is greater than 20 kilohertz, it is a high frequency sound wave, high energetic sound wave. This is sensitive to bats. Bats can hear these sound waves. Now, in this ultrasonic wave topic, we are going to see what is meant by ultrasonic wave, what is the property of ultrasonic wave, how you are producing. We can produce ultrasonic wave by 3 methods actually: Galton whistle method, piezoelectric method, oscillator, and magnetostriction oscillator. So, in your syllabus, you are having only piezoelectric effect and magnetostriction effect. Based on that, there is an oscillator circuit, electronic oscillator circuit, which will generate an ultrasonic wave. So, we are going to see the concepts only. Then applications of ultrasonic wave. Now, what is ultrasonic wave? Ultrasonic is made up of 2 words. Ultra means beyond. Sonic means sound. Sound waves whose frequency is above the limit of humans' audibility, that is greater than 20 kilohertz, is called ultrasonic wave. Now, the spectrum of a sound wave, generally a sound wave whose frequency is less than 20 hertz is called infrasound. And example, earthquake. Then 20 hertz to 20 kilohertz, this frequency range is called audible sound. Music, noises, unwanted noises, these are all audible sound. Then sound wave whose frequency is greater than 20 kilohertz is called ultrasonic, which is sensitive to human ear. It is not sensitive to human ear, it is sensitive to bat. The sound produced by the bat is also come under this ultrasonic wave. Now, what are the properties of ultrasonic wave? You know that E is first, you must know, E is equal to h mu. Energy is equal to h Planck's constant mu, frequency. So, when the frequency of the sound wave, ultrasonic wave is a sound wave of having high frequency, means automatically when the frequency of the sound wave is high, the energy of the sound wave is high. So they have large energy content. E is equal to h mu. And you know that E is equal to h mu is also equal to hc by lambda. So energy of the sound wave is more means if the frequency of the sound wave is more, it is a highly energetic wave. At the same time, the wavelength of the wave is small. So the smaller the wave, they can be transmitted over a long, smaller the wavelength of the wave, they can be transmitted over a long distance without appreciable loss of energy. Shorter, because ultrasonic wave is a high frequency wave greater than 20 kilohertz. So automatically energy is more. So it is highly energetic wave. Once the energy is more, then wave, and because the frequency is high. Once the frequency is high, the wavelength is small. So ultrasonic waves are sound waves having shorter wavelength. Because it is a shorter wavelength, they can be transmitted over a long distance without appreciable loss of energy. Then next, how will be the velocity of ultrasonic wave? See, the velocity of ultrasonic wave depends upon the temperature and frequency of the medium through which it propagates. So it depends upon the temperature and frequency of the medium through which it propagates. The velocity of ultrasonic wave vary. That is, indirectly we can say that depending upon the density of the medium through which it propagates, the velocity of ultrasonic wave will vary. For example, in the case of a light wave, when the density of the medium, am I audible? Whether you are reaching me, any one of them?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
Okay. If there is any problem, you unmute the mic and tell me. Okay. Now, when the velocity, you know that the case of a light wave, when it propagates in a medium, depending upon the density of the medium, the velocity of the light wave will vary there also. How it vary means, when the density of the medium is more, velocity of the light wave will be less. That is, when a light wave is propagating through air, its velocity is very larger. That is, even light wave will travel through vacuum because it is an electromagnetic wave. So even through vacuum it will travel. When the vacuum, there is density is very, very less. There is no density. So in the velocity of light wave in vacuum is 3 into 10 power 8 meter per second. Same light wave, when it travels through glass density is more compared to that of air. When it travels through the glass, the velocity of the light wave will reduce. So density of the medium increases, the velocity of light wave will decrease. But in the case of a sound wave, now we are ultrasonic wave is a sound wave. So in the case of a sound wave, when the density of the medium increases, the velocity of the sound wave also increases, just opposite to light wave. Because sound wave, that is one type of sound wave is this ultrasonic wave. It is not an electromagnetic wave. It is produced by the vibration of the particles in a medium. So for an ultrasonic wave or any sound wave, whether it is infrasonic or audible, the sound waves are produced due to the vibration of the particles in a medium. So medium is necessary. Because of that only, velocity of sound in air, we will tell. That is 330 meter per second. But for a light wave, there is no necessity for medium. It will travel through vacuum. So because light wave is an electromagnetic wave, but sound wave is not an electromagnetic wave. It is produced by the vibration of a particles in a medium. So medium is necessary. Because of that only, velocity of sound in air, we will say. It is about 330 meter per second. So now, what I am going to insist you is, so medium is necessary for the propagation of sound wave. So when a sound wave propagate through a medium, depending upon the density of the medium, the sound wave velocity also changes. But how it changes means it's just opposite to the light wave. When the density of the medium is more, the velocity of ultrasonic wave also will increase. Why means, if the density of the medium is more, the number of particles present per unit volume, number of particles present per unit volume is more. So when sound wave means it is produced by the vibration of the particles in a medium. So more the density of the medium, more will be the number of particles present per unit volume of the medium. As a result, what happened? There is a more vibration of the particles, and more will be the greater will be the velocity of the ultrasonic wave. So density of the medium increases, the velocity of ultrasonic wave or any sound wave will increase, which is just opposite to that of the light wave. Light wave, density of the medium increases, velocity of light wave will decrease. Because it is, light wave is entirely different. It is an electromagnetic wave, but sound wave, it is not an electromagnetic wave. It is produced by the vibration of the particles in a medium. So when the density of the medium increases, velocity, more will be the number of particles present per unit volume of the medium. So more will be the velocity of the ultrasonic wave or any sound wave, whether it is audible or infrasonic wave. Generally, for a sound wave, when the density of the medium increases, velocity of the sound wave will increase. Now we are talking about particularly one type of sound wave whose frequency is greater than 20 kilohertz. Now, like ordinary wave, that is like light wave, ultrasonic wave also get reflected, refracted and absorbed in a medium. When an ultrasonic wave propagates through a medium, a part of the ultrasonic wave may be reflected, some amount of the ultrasonic wave may be refracted through the medium, some amount of ultrasonic wave may be absorbed by the material of the medium. These are all some properties. Again, this is another important, another type. They have a high energy content. Same thing I am telling. Speed of ultrasonic wave depends upon frequency. Frequency of the more will be the, if the frequency is more, energy of the wave will more. So the speed of the ultrasonic wave also depends upon another parameter called frequency also. To propagate, apart from density of the medium, it also depends upon the frequency of the ultrasonic wave. That is, what is the meaning for the second point is, if you are having two sound waves, one sound wave is having a frequency 200 megahertz, another sound wave is having frequency 400 megahertz. Both the sound waves are ultrasonic wave, because 200 megahertz or 400 megahertz, megahertz means 10 to the power of 6 hertz. So it is greater than kilohertz. So both are sound waves having high frequency. They are called as ultrasonic wave. One sound wave is 200 megahertz, another sound wave is 400 megahertz, means this 400 megahertz sound wave is high frequency ultrasonic wave compared to that of the 200 megahertz ultrasonic wave. So whose velocity, speed or velocity, what do you mean by, okay, wait, I will tell you. Whose speed is more means the sound wave whose frequency is 400 megahertz is more. That is the meaning. Speed of the ultrasonic wave depends upon frequency. More the frequency, higher the frequency, more will be the speed of the ultrasonic wave. Now, I want to tell you here, what is speed? Speed is vector quantity, is velocity. Velocity of the wave means it is a vector quantity. This much meter per second, in this direction it is going. Speed is nothing but scalar quantity. That is, this much meter second, this wave is going. That's all. In which direction it is going, you are not saying. So, speed and velocity, what is the difference? Means speed is a scalar quantity. Only this much meter per second, you will tell. You won't say in which direction that wave is propagating. But if it is a velocity, this much meter second, the sound wave is propagating in this particular direction, left to right or towards north, like that. If the direction is that, then it is a vector quantity, then it is called velocity. Okay. Now, to propagation of the ultrasonic wave, a medium is compulsory. That I have already told you. Then this point is also, it is shown in that slide itself. Just like ordinary sound waves, ultrasonic waves get reflected, refracted, and absorbed. Polarization cannot be polarized. Light wave can be polarized. Okay. That is the vibration of the particles in same direction. That is vibration of light photons in a same direction. It is called polarized light wave, we will say. So polarization is not a property of a sound wave. It is a property of a light wave. And next is, sixth point is source negligible diffraction. You know what is diffraction? Diffraction is one of the properties.
Excuse me, ma'am.
Tell ma.
Ma'am, your screen is not visible, ma'am.
Now. It is not visible. Why?
No, ma'am.
Somebody is presenting. Wait, ma. I will see. I will check. What is the reason? Resume presenting.
Yes, ma'am.
You are getting up,
Yes, ma'am.
Okay. Now, see, negligible diffraction. What do you mean by it? Diffraction, what is it? Means when a wave propagates, when it is propagating in a particular direction, on its path, if there is any obstacle, hindrance, the wave will bend around the edges of that obstacle and propagate. This diffraction phenomena you can see in light wave. That is, when a light wave propagates, it will travel in a straight line over a long distance. On its path, if there is any obstacle or hindrance, the light wave will bend around the edges of the obstacle and then proceed. This phenomena is called a diffraction. This diffraction effect is shown in, you can see in light wave. But in the case of sound wave, there is a negligible diffraction. Why? Means that is in the ultrasonic wave, not in another in audible or infrasonic. In the ultrasonic wave, you are getting a negligible diffraction. Why? Means, see, the wavelength of the wave is very less because its frequency is high. It is highly energetic wave. E is equal to h mu, but E is also equal to hc by lambda divided by lambda. So because its frequency is high, it is a wave of shorter wavelength. Ultrasonic wave is a sound wave having shorter wavelength. So because of it, if there is any when an ultrasonic wave propagate on its path, if there is a obstacle, the sound wave, there is a possibility for the absorption of the sound wave by the obstacle, then bending around it and travel. So because its wavelength is so smaller, the diffraction will never take place. The sound wave will be absorbed by the medium. It won't, the sound wave, when it falls on the obstacle, it won't bend around the obstacle and propagate. Diffraction will never take place like light wave, because ultrasonic wave is a sound wave having shorter wavelength. So there is a negligible diffraction effect. Now next is acoustical grating can be constructed. That we have to see in detail when we are when the bridge course is extended from normal class or something. These things will be explained in a better manner. Acoustical grating. You can form a sound using a sound wave. You can form a grating. You have seen in the glass grating in the spectrometer and all, a glass plate which is ruled with a ruled with a diamond tip, so that each ruling on the glass plate will be obstacle for the light wave. Between the two rulings, there is a transparent glass plate which will act as a slit. That is called a optical grating. Like that, when you take a beaker and through the beaker, you are filling the beaker with a liquid, and we will allow the ultrasonic wave to pass through that liquid in a beaker. So you know that ultrasonic wave will propagate in the form of a crust and trough. When the ultrasonic wave will propagate in the beaker, liquid of in the beaker containing liquid, wherever the crust is formed, crust region is there in the liquid, because of this ultrasonic wave propagation, that region, the liquid will be having a high pressure region. The liquid pressure will be high. The density of the liquid, number of liquid molecules present in that particular point where the crust is formed is high, and where the trough is formed in that particular region in the liquid, the pressure will be less. So this high pressure region will act as a ruling, and this low pressure region will act as a transparent glass plate. So the whole beaker filled with a liquid where the ultrasonic wave passed, and as a result, in the liquid region itself, layer by layer, one layer of the liquid is a high pressure, a high denser region, another layer of the liquid will be a low pressure region. Because of that, the whole arrangement will be like a optical grating, where in the glass plate rulings are drawn. So the acoustical grating can be constructed when an ultrasonic wave passes through a beaker containing liquid. That is the acoustical grating. This is one of the property. I will tell you in detail later. Now, next is important property for practical application. Apart from this, there is a main property which you should always keep it in mind. This is a very important property. That is, when an ultrasonic wave travel from one medium to another medium. That is, when an ultrasonic, you are taking an ultrasonic oscillator and you are generating an ultrasonic wave, and the ultrasonic wave is going to travel from air to glass. So one medium to another medium. When it is traveling, there is a boundary separating the two medium. At that boundary, a part of the ultrasonic wave will be reflected. When a sound wave is reflected, it is called as echo. Why this happen? Means when an ultrasonic wave travel from one medium to another medium, at the interface or at the boundary separating two medium, a part of the ultrasonic wave will be reflected back as a echo. Why this happen? Because each medium will have its own acoustical impedance. What is acoustical impedance means? Acoustic means sound. Impedance means resistance. Each medium has its own resistance to propagate allow the sound to pass through it. So each medium has its own resistance to allow the sound to pass through it. That is called acoustical impedance. This acoustical impedance will vary from medium to medium. This acoustical impedance, that is sound resistance, is measured by the word, it is indicated by the word Z, which is equal to rho V, where Z is equal to rho V. Z is acoustical impedance, rho is called the density of the medium. Each medium has its own density. When a sound wave is traveling from air to glass, air is having one density, glass will have one density. So rho is the density of the medium. V, the velocity of ultrasonic wave through that medium. Am I correct? I have already told you, depending upon the density of the medium, velocity of the sound wave, ultrasonic wave, generally sound wave will vary. More the density of the medium, more will be the velocity. So each medium, in air, if the sound wave is traveling with a velocity 330 meter per second, because ultrasonic wave is a sound wave, where in the glass, its velocity will be what? More than this 330 meter per second, because the density of the glass is more compared to that of air. So in air, 330 meter per second means in glass it may be moving with a velocity 345 meter per second. So because more the density, the more will be the velocity. So this acoustical impedance in each medium for air or glass is depend upon Z is equal to rho V. That is, for air, the acoustical impedance Z1 is equal to rho 1 into V1. Means rho 1 is the density of the air, V1 is the velocity of ultrasonic wave through air. Then Z2 is the acoustical impedance of glass, means rho 2 is the density of the glass and V2 is the velocity of ultrasonic wave through the glass. So when an ultrasonic wave travels from one medium to another medium, there is a change in acoustical impedance from medium to medium. As a result, at the boundary separating the two medium, there is a part of the ultrasonic wave will reflect as an echo. This is called, this is an important property for the any practical application of ultrasonic wave. A simple example I will tell you. See, you have heard about scanning a body, human body, ultrasonic scan. You have heard about it. See, they will take a transducer and keep on the human body. When they are keeping the transducer, which is generating an ultrasonic wave on the human body, from the transducer, ultrasonic wave will generate and it will pass through the skin, and over below the skin there will be a vein or some muscle layer, vein, bone, like that. So ultrasonic wave will travel from the transducer to different medium, different layer, through the skin, through the muscle, through the veins, through the bone, like that different layer the ultrasonic wave will propagate. So each layer is having each layer is each different medium. Each medium will have its own acoustical impedance. So when because of that, separating the two layer at the boundary, a part of the ultrasonic wave will reflect back as a echo, and this is collected by the receiving transducer and it is recorded on the screen, so that you will get the cardiographic result or scanning result, everything. By collecting the reflected echoes at the different layer, you will form a scanning graph, A scan or B scan or ECG or anything you will do, means only this is the technique. So like this, one example, this is a medical example. Apart from that, from the reflected echoes at the different layer boundary, only we are getting the information about the scanning information about the body. Or another example based on this, see, ultrasonic non-destructive testing is there. You are taking a huge machinery part and you are manufacturing a huge machinery part, and you want to find whether inside the depth of the machinery part any defect is there. If it is so, you cannot you cannot break the machinery part which you have spent a lot of money and you have fabricated it, you have produced it, and you cannot broke it and find if there is a defect on its depth. You have to do a non-destructive testing. In that case also, the ultrasonic wave will allow to pass through the transducer, and when it is through the transducer, the ultrasonic wave will pass through the machinery part, and if there is any defect, that region will be, there is a change in the medium. So at the interface of the defect and that machinery part, a part of the, due to change in the medium, there is a change in acoustical impedance. So at the interface separating the two medium, a part of the ultrasonic wave will reflect as an echo. From the reflected echo, at which time this echo is seen on the screen, with the time of propagation of this ultrasonic wave through the machinery part and reflected back, that time difference, and it is directly calibrated on the screen with the depth, at which depth the defect is there, like that. This principle, this property of the ultrasonic wave, which is seen in the PowerPoint now, when an ultrasonic wave travel from one medium to another medium, there is a change in the acoustical impedance of the medium. So at the interface separating two medium, a part of the ultrasonic wave will be reflected as a echo. This is an important property. What is acoustical impedance is Z is equal to rho V. Rho is the density of the medium and V is the velocity of ultrasonic wave through the medium. So this is also an important property. Next, how will you produce ultrasonic wave? Actually, three methods are there to produce ultrasonic wave. One is Galton whistle method. There is electric generator and the generator or oscillator. Now in this bridge course syllabus, we are going to give a we are not going to for the entire this thing. Just we are going to give what is magnetostriction effect and what is piezoelectric effect. Then how this effect is applied in an electronic oscillator circuit to generate an ultrasonic wave, you will detailedly study in the main classes. Now, just magnetostriction effect. What do you mean by it? What is the physics of magnetostriction effect? And what is piezoelectric effect? That only we are going to see. Now, what is magnetostriction effect? How much time is there, Pa?
2 minutes.
2 minutes.
Shall we take the attendance?
No, ma'am.
Because this is
Yes,
a very
ma'am.
good topic. We will see in Friday. On Friday, we will see this class. Okay.
Okay, ma'am.
Okay,
The
ma'am.
PowerPoint, if you form a WhatsApp group, we can share this PowerPoint to you. I will give you this PowerPoint also. Material. Okay.
Already attendance.
Where it is, I am not there. It is already there. You can add me if it is there. Okay? Already it is there with your class advisor. I am your class advisor, no?
Gomati, ma'am.
Gomati. Okay, tell Gomati ma'am to include me also. Okay?
Yes, ma'am.
I will also talk to her. Okay. Magnetostriction effect and piezoelectric effect, I will talk to you in next class in detail. Okay. If you, whether you can follow me?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
If you
Yes,
have
ma'am.
anything, you can contact me and you clarify the doubts. Okay. I will help you to understand the concept. If you are somebody you can't understand, you ask me, I will help you in these topics. Okay. Now answer your attendance. Wait, I will tell you. From 49, am I correct? Mohammed Yasir.
Present, ma'am.
Mohammed Yasir.
Present, ma'am. Present.
Mohan Kumar.
Present, ma'am.
One by one, you mute and tell next name. 51. Who is 51?
Ma'am, Mukil present, ma'am. 51.
52.
Ma'am, Muralidharan present, ma'am.
Next. 53.
53. Nakul present, ma'am.
54. Quick.
Yes, ma'am. Now present, ma'am.
55.
Nishant present, ma'am.
You have to unmute the mic and unmute your video and you have to tell. Then only it is nice, I think. I can see your faces also. Am I correct? Okay, next. Pavitra.
Yes, ma'am. Present.
Then, next. 57.
Present, ma'am.
What's your name?
Ma'am, Purna Chandur.
Then 58.
Ma'am, Pragati is present, ma'am.
59.
Rahul present, ma'am. Raghuram present,
Yeah.
ma'am.
Next, 61.
Rahul is present, ma'am.
62.
Rakesh present, ma'am.
63.
Ramanathan present, ma'am.
64.
Renish Raja present, ma'am.
65.
Kumar present, ma'am.
66. 66. Absent. 67.
Sadasivam present, ma'am.
67.
Sadasivam present, ma'am.
Okay, good. 68.
Sahitya present, ma'am.
69.
Saktivel present, ma'am.
69. What's your name? Saktivel.
Yes, ma'am.
70.
Samvartana present, ma'am.
71.
Sanchit present, ma'am.
72.
Sanjay present, ma'am.
73.
Sanjeev A present, ma'am.
74.
Sanjeev B present, ma'am.
75.
Santoshi present, ma'am.
77,
Santosh Kumar present, ma'am.
78, 79,
Sibiraj present, ma'am.
80,
Siddharth present, ma'am.
81,
Shivashankar present, ma'am.
82,
Felix present, ma'am.
83,
Subhash present, ma'am.
84,
Sugan present, ma'am.
85,
Suganeswaran present, ma'am.
86,
Sujeshwar present, ma'am.
87,
Suman present, ma'am.
88,
Suvita present, ma'am.
89,
Tambiraj present, ma'am.
80,
Tambiraj present, ma'am.
89, okay, 90,
European present, ma'am.
91, 92,
Varshni present, ma'am.
93,
Vasant present, ma'am.
94, 94, 95,
Vishnu present, ma'am.
96.
Yashwant present, ma'am.
So three of you are absent. Who's this? Sadanand, Saradi, Vaibhav, Ramanan. These are all absentees. Then, okay, if you have any doubt, you can ask. Till 2-3 minutes is there, I think so. If you have any doubt, you can ask. Unmute the mic and you can ask if you have any doubt.
Ma'am, your mobile number, ma'am.
It is in the timetable, it is there, no? Malathi? It's not there. Okay. Take it. 96 290 38877. Wait, I will put in the chat box. 96290 38877. You see in the chat box.
Thank you.
Thank you, Ma. You can leave there if you want.
Thank you, ma'am.
Okay.
Thank you, ma'am.
Thank you, ma'am.
Thank you, Pa. We will see you next Friday.